Today we're going to be discussing triangle congruence and proving them congruent. So we're starting out with side-side-side congruence. If the sides of one triangle are congruent to the sides of a second triangle, then those triangles are congruent. And that abbreviation is SSS. So instead of having to write out side-side-side congruence, we just write SSS. So what this looks like, so if AB is congruent to ZX, BC is congruent to XY, and AC is congruent to ZY, then we know that those two triangles are congruent because of side-side-side. So we're going to do a proof. So our given tells us segment AB is congruent to AC, and BY is congruent to CY. Okay, and what this actually looks like, we have a triangle, and it's actually cut into two. And we're going to be labeling these A, B, Y, and C. Okay, so those are the triangles that we are looking at. We're going to try to prove that BYA, triangle BYA, is congruent to CYA, triangle CYA, on this side. Alright, so we always start out with our given. So we have AB is congruent to AC. So I'm going to mark that. AB is congruent to AC. We also know that BY is congruent to CY. So I'm going to mark those. BY is congruent to CY. Okay, and that was given. So then our next step here, the only one that we don't have is this one right here. So I'm going to say AY is congruent to AY, and that is our reflexive property. Okay, so now we have this one. So if we have all three sides, we can say triangle BYA is congruent to triangle CYA, and that is side, side, side. These two sides, and then the center one. Okay? Alright, let's look at another one. So now we're going to look at this in relation to coordinates. So you can graph this if you would like to. I'm not going to for this example, just because we're going to be determining if these two triangles are congruent, and we're using the distance formula for that. So I don't necessarily need to have it graphed in order to be able to use my distance formula. So we're going to be proving that RT is congruent to JK. Excuse me. So RT, if you remember our distance formula, we're taking x minus x, so we're looking at R and T here. X minus x, we have 2 minus 5 squared, plus y minus y, which is 5 minus 2 squared. And then we're going to come over and look at JK. So we have J is here. So we have a negative 4, K is here. So minus a negative 7 squared, plus our y's, 4 minus our y here is 1 squared. Okay, so now I'm going to go ahead and find the length of those pieces using this formula. So 2 minus 5, we get a negative 3 squared. 5 minus 2, we end up with 3 squared. Square root over that. A negative 3 squared is 9, plus 3 squared is 9. So we have 18, and then the square root symbol. Same thing for JK. We have a negative 4 minus a negative 7, so we make that plus a positive. So the difference between 4 and 7 is 3. So we have 3 squared, plus 4 minus 1 is also 3, and that is squared. Square root symbol. 3 squared is 9. 3 squared is 9. So we end up with square root of 18. So we can say yes, those are congruent. Okay. The next one is going to be TZ. TZ. And TZ goes with KL. So square root symbol. We're looking at T and Z. So right here are x's. So T is 5 minus 1 squared plus our y values, which is 2 minus 1 squared. And then for KL, KL are here. So we have square root symbol. Sorry for that interruption. So we're working on KL. So K is a negative 7 minus L, which is a negative 3 squared, plus our y values, 1 minus 0 squared. So then we're going to go ahead and work those out. 5 minus 1 is 4 squared. 2 minus 1 is 1 squared, and then our square root symbol. And then we have 4 squared is 16. 1 squared is 1 with our square root, so we have square root of 17. KL, we have a negative 7 minus a negative 3, so that's plus a positive. Since this is a negative and that's a positive, we want the difference. So we have 4, and that's a negative 4 squared, plus 1 minus 0 is 1 squared, so that's a square root. Negative 4 squared is 16. 1 squared is 1. Square root symbol, so we have square root of 17. Are they equal? Yes. So those are congruent. Okay. Looking at the last one, we have the first and last letters for our triangle. So we have R, Z, and we have J, L. So for RZ, we're looking here. So square root, x values, 2 minus 1 squared, plus our y values, 5 minus 1 squared. And then for JL, looking at J and L, square root symbol, negative 4 minus a negative 3 squared, plus 4 minus 0 squared. Okay, so I'm going to go ahead and move this up now. So again, we're going to work the RZ side first. So 2 minus 1 is 1 squared, plus 5 minus 1 is 4 squared, and then we have our square root symbol. 1 squared is 1, 4 squared is 16, so this is square root of 17. On the right hand side for JL, negative 4 minus a negative 3, so we plus a positive, so our difference there is a negative 1 squared, plus 4 minus 0 is 4 squared, and our square root symbol. Negative 1 squared is 1, plus 4 squared is 16, so we end up with square root of 17. Those are congruent. So since we have all 3 sets of sides are congruent, then we can say yes, triangle RTZ is congruent to triangle JKL because of side, side, side. All right? Great job. So let's look at some more vocabulary. So the next one is side angle side. So if we have two sides and the included angle, this is really important, of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. And that is side angle side, SAS. So before I go into this picture, I do want to discuss included angle. Included angle means the angle that is formed by two sides in a polygon. So now if we look up at the picture, if I have one side which is AB and another side which is CB, what angle is formed by those? Well, that would be angle B. If I look over here on this one, we have FD and we have ED. The angle formed by those two is D, so that is the included angle. Okay? Alright, so let's look at another proof then. So for this one, we're given that X is a midpoint of BD, and X is the midpoint of AC. And so then we're going to prove that triangle DXC is congruent to triangle BXA. And what does our picture look like for this one? Well, it actually looks kind of like a parallelogram. So we have a shape like that, and then we're going to cross them. So we have our diagonals. So we have D, A, B, C, and then X is in the middle. Okay? Alright, so we always start out with our given. So X is midpoint of BD, and X is midpoint of AC. This was given. So then from there, because of midpoint, we can say that DX, this piece here, is congruent to BX, this one here, because of the midpoint theorem. Or definition of midpoint. Okay? We also know that CX is congruent, this one here, is congruent to this piece, which is AX, and that's the same reason. It's our midpoint theorem. Okay, I'm going to go ahead and mark those. This one with this one with this one. Okay. Next, I'm going to say angle DXC is congruent to angle BXA. So let's look at those. DXC, it's this one right here, is congruent to BXA, that's this one over here. And the reason for that, those are congruent because they are vertical angles. Okay? So I marked those. So then let's go back to what we're trying to prove. We're trying to prove that DXC, this triangle here, is congruent to BXA, this triangle over here. Well, right now we have a side on both, an angle, and then a side. So that is side, angle, side. We have the included angle, the angle between my two sides, and then those two sides, obviously. So then we can say triangle DXC is congruent to triangle BXA, and that was side, angle, side. Okay? That is it for today. Have a great evening. I'll see you in class tomorrow.